Hello and welcome to PyCon SE 2020, and let me introduce our next speaker. His name Olof Bjarnason, and he's a senior software developer, GAN technical agile coach.
Hello everyone, let me get the presentation running. So welcome to this talk. So this talk is called Refactoring Legacy Code Without Hesitation, or Slay That Beast. I'm Olof Bjarnason. I work as a technical agile coach at ProAgile. I'm a software craftsman based in Gothenburg, Sweden. So do you recognize this scenario? You curse once again at the monster function that needs to change. Will you add some technical depth with another if block or spend the day carefully adding tests trying to understand it? The monster stares back at you and smiles. You add another if. So there is another way. You can use approval testing. This talk will demonstrate the technique and give you an idea how it works. So I just want to mention that it's not a magic shield. You will need to learn how to build a shield and how to wield a shield. So briefly about this talk. We got some intro slides first, and then I'll demo the production code. Then we'll spend some time protecting the production code. We'll build a shield approval test. And then we will refactor the production code. And then we have some time for QA. So, code starts out small and simple. It's like an elegant little fox. It's easy to understand. It's well written. But if you do not put some effort into design and patterns and adding automatic tests, soon it will just grow into an uncontrolled beast. So today we're not going to look into a dragon. We're going to look at a boar, kind of. It's 120 lines of messy code. It's got two different concerns in one. It's got no automatic tests yet. And it's very un-Pythonic code, so cover your eyes. So it's time for demo. So this is the boar. It's a script that's run in production at ProAgile, where I work. And also we've added a second concern just for this demo. So it's real production code. So I'll just briefly explain what it does. So when we run it, we get this report in the console. It's basically showing so-called single attendees to the courses we provide at ProAgile. So we give courses, among other things, we give courses in agility. And we have noticed through the years with experience that if you want a better impact on your company, you should have at least two from your company attending. So this script basically just checks where do we have single attendees, so we can contact and try to get two for better impact. And then it's got a second concern, in the end, a second report basically, which checks the future courses where we have a wanted, how many attendees we want in a course, and then we have this classification. Red, it means haven't reached our goal. Yellow means we haven't reached yet, but it's a bit into the future. It's 2 weeks, or at least 2 weeks into the future. So there is some time still, but it's yellow. And then we have this green classification, which means we have reached our goal. So this is basically what the board does. It's, as I said, 120 lines of quite messy Python code. So it starts here. And it runs. And it looks like code does look. It's some commented out code and not Pythonic variable naming and a lot of if and for loops and else. And yeah, you know how it is. Real code. So what I'll do now is add an approval test. So I just create a new file, which we'll call test sales. And we'll use a library called approval tests. This library is available from all languages than Python, by the way. So we'll just call it test war. So I'm writing a basic PyTest unit test here. And then I'll just call this function verify. So what is happening here? So verify captures what you give it, hey, into a received file on the left here. Test sales, test bore. It's named after the unit test. So test sales, the module, test bore, the unit test received. So this is what it got, basically the input to the verify function. And here on the right-hand side, we have the approved version. So this is what I approve as a human, tester developer. So I just add this to the approval file to approve this is the expected output. Right now it's just hey, which means hello in Swedish. So if we run it again, we have the tests here down here. It's just green. The same thing happened. So we've kind of captured this. So what we want to do now is to run the actual production code in our test. So I'll just copy what is run here into the test. I have to import this. Run it again. So now it will just run just like it did before. So we get this console report here. So let me just briefly explain what we're trying to achieve. So this script is getting popular at ProAgile. It's being used, but right now it can only be used by Pythonistas on ProAgile because you have to run it like this. So we want to make a modification or extension to this script to generate HTML code. But since it's running in production, we're quite cautious about preserving this functionality, not damaging it. So that's what we're looking to do. And right now we're building this shield I showed in the presentation. So to start building the shield, we'll look for what Michael Feathers in his classic book, Working Effectively with Legacy Code, calls a seam. So what we're trying to capture the effect of this code. So what it's really doing is printing, simply printing. It's doing calculations and printing. Printing, and it's doing it from this input data. So we'll do this little trick now to capture this effect. We'll import that module, and then we'll just replace the print with a fake. And we'll append whatever comes to our list. And then we'll replace this variable, the result we're verifying, with this output, the real output. So now when we run the test, we won't print to the console, we'll print to this fake print instead. So let's run it again. So now we're capturing kind of the effect of this production code. We are getting the output here in our received file, and as I told you before, the approved is still hey. That's just what we captured first. So this is the actual production code being run with real data. And we say that's fine. Even if there's bugs in it, that's fine. We just want to capture what it's doing. So we save that, we approve this into the approved file. Let's run it again to see if it's the same. If it's behaving the same. So now we're testing running the production code again. Of course, if someone signs up to a course of ProAgile, or what? Let's check this. So no company entered. ProAgile course models attendee object at this thing. It looks like a memory address, right? So this is something you have to work with approvals, is that some things are not deterministic. In this case, we have memory addresses coming out of the production code, and we're not really interested in exact memory addresses of the attendees here. So let's look at that row. So it was no Let's find it in the bore. No company entered. So here. So this is the row that produces this memory address. It's just printing this a attendee variable straight out. So what we'll do here is we will just say that we're not really interested in this memory address. So if we get a string that starts with a string, we'll just add that and not the latter part. We're not interested in the memory address. Let's run it again. So we're kind of filtering the output of the production code here, the effect, to show what we are interested in. We're not really interested in this memory address. We'll just filter it. Okay. So let's approve this new version of the approval file. And now hopefully we're deterministic. Great. So we got our deterministic behavior of the production code now. The next thing is, as you've noticed, it's quite slow to run this. So we want a quick cycle time, a really short cycle time. So to do this, we'll try to not hit the real Amazon Web Services, which is being used here to fetch the data. We'll use some fake data that I happen to know is available in this system. So in the code, in the bore, this is the input. This course caches, which hits Amazon. And instead of using that, we'll use the fake data, which also has another good feature, and it's that if someone signs up right now when we're doing this or cancels attendance, it will fail the approval test. So it's even more reproducible, so to speak. And so the fake data is just in fake course caches. So now we'll have a new output, of course, because it's now new input data. So let's approve this new fake data. Run again. So it's a lot quicker, as you can see. So it's more reproducible and a lot quicker. So what we'll do now is check how much of this code are we covering. So we're building a shield, and we want to see how much of this code are we now capturing in this approval test. So for this, we use coverage. And we can see soon how much of this code is being covered by the shield. Okay, so a lot of green. Okay, we got a red section, another red section, a third. So there's a lot of green, but there are some red sections that we have to try to improve the shield now to get full coverage. So let's start with a code we've already looked a bit on, this no company entered case. So to reach this piece of code, we have to make this condition false. So basically, this attendee object has to have a null company. So the easiest way to do that is just to change the fake data. So let's add another attendee on the same course. Oops. So we'll add Ellen. And she's from no company, so to speak. And let's run it. So we got new data here. No company entered. Great. We of course got two attendees now to this course. So this is expected. This changes to the input. We'll approve it. Now let's run. Let's just see its screen. Yes, and let's run coverage again. So we are hoping this is green now. It takes some time to cover, so it's good that we're not hitting the production. Okay, green. We are green. Great. So let's look at another part of this. So this classify, this is what selects the right classification for a course. So let me just run the script in for real again once, and I'll just explain what's going on here. So we got 3 classifications: red, yellow, and green. So yellow is when it's 2 weeks in the future, but not filled yet. Red is when it's within 2 weeks and not filled. And green is when it's filled, regardless of time. So to make this piece of code execute, we have to have the number of signed up larger to or equal to start guarantee threshold. So the easiest way to do that, again, is to modify the input data. So let's find the course instance of course. So this is the course instance, which Ellen is on, and it's got this actual course type. So let's yeah. So this is a bit about the data model. It's not. So I'm looking through the input data to find this course. And here's the right attribute, start guarantee threshold. So it's 6. So the easiest way to get that green case to run is just lower this to 1. Let's approve the change. Oh, sorry, tests. So notice it's now 1 on this PSPO course. We'll approve it. It goes green, and let's check the coverage. So we're hoping to get this covered. Cool. These approval text files, they show up here beside the test. So here's the test. Here's the approved file. So we capture it we keep it in the repository just beside the unit test, and it's really part of the testing of this system. So here's the output, and if you notice here, there is no yellow course. Everything is red. And then we have the green that we produced just now. So why is this? That's not really possible, because the first course, if you remember, it's 2 weeks in ahead to get a yellow course. This is 2019, and the last one is 2020. So that's way more than 2 weeks. So something is really strange here. So let's debug into this classify to see what's going on. Okay, so days until start is negative number. So days until start, it's a future thing. So it can't really be negative. Something is really off here. Let's go up a step and see what the caller is doing. So it's got some code. It's doing this classify for real call. Days until start is computed by this expression, and now comes from a side effect. So this is the computer's clock time, which is absolutely not deterministic, because it changes every time we run the test. So we'll try to fake this behavior. We want it ideally to be the same as the fake data. Fake course instance, it's got this state. So we want it to be the same. So to do that, we can try to do the same thing as with the fake print. We'll just switch that behavior. Daytime UTC now. We'll put in a lambda. Yes, we need to import that. So we're just making sure that the production code is using this same data as the fake data. Let's run that. Boom. So we didn't get the diff tool this time. What's going on? we got an exception. Type error, can't set attribute of built-in extension type datetime, which is makes sense. You can't change attributes of the built-in types in Python. Maybe there is some magic trick, I don't know. But for now, we're going to use another method. So when you do approval test, you really want to keep from changing the production code. You want to do this faking and this mocking as much as possible, because you care about your production code. You don't want to change it easily. That's why we're building this shield. But sometimes you really have to do a very careful change. And then when you do that, I prefer to do automatic refactorings as much as possible, because they're a bit safer than manual refactorings. So we'll just introduce a method in this class for this functionality, which we can fake in the test. So UTC now is just doing the same thing. I extracted a method there. And then we can move this datetime UTC now fake into the SUT instead of the module level. So now it's just faking it inside the class instance instead. And we got yellow courses. So now sanity is restored. We approve this change, and hopefully, let's say it's green. Let's say it go green, yes. And hopefully we got some more coverage now of the bore. So we're building our shield, getting higher coverage. Okay, so this is red still, but we have mocked that, so it's not expected to be green. More and more green. Ooh, that's a one section that's left still. This is completely covered. So we got this case left, the else here. So how will we cover this one? This we have to make. Oh, this is a global variable, and we have to make it false. So really ugly hack here to make classification flag false. Where is it? Here is it's defined here. We'll do this. So we can extract this whole section of the code into a separate method. In fact, let's do it step by step. So we can change that global variable in the module by doing this. So right now it's true. That's what it's defined as to start with here. But we can, if we introduce a variable, let's call it, oops, let's reverse that and make it proper. Flag. Let's call it flag. So now this is the default way we have run it so far. We'll extract this to our method run bore maybe, which takes this flag. Let's run that approval test. So we're basically doing the same thing again. But now we can change that behavior, getting to the else, with flag false. So we're adding a second approval test, second unit test to cover that case. And we have to run it, the full file, not only that test. So when we got to the second test, so this is the second one, second case. Let's see what difference it made. So we have another sorting here. It's mixed now between categories. It's sorting on dates instead in the report. That's what the classification flag does, apparently. Let's approve that test and run both of them again. Cool. So what is our coverage now? Great. We've covered our whole bore. It's fully covered. So what you do now when you have full coverage is what you want to improve this shield. You want to find weaknesses in the shield by doing something that's called mutation testing. So you basically change code to see if the shield protects you. So if I change this line of print code, this print, I got an alarm. I got the test protecting me. I made a change that's dangerous. So that's good. So any print statement really will be captured. Let's try changing this value. So now we're looking for weaknesses. This is second phase. We're looking for weaknesses in the shield. That was caught too. And so that's good. And you basically do look for conditions and edges of the code, kind of. So trying to change things and see if things break. So any print statement will be found, right? If I do this, I doesn't even enter the test. It crashes with some syntax error. That's good. It's an error too. We captured. Great. So if you want to do this, increase the confidence even more, you can use a tool called Cosmic Ray. So let me show you. This is a tool for Python that's called Cosmic Ray. It basically automates what I'm doing now, mutation testing, to find things that are still weak in your shield. Let me show you an example of how our shield is weak right now. It's if you change this number to 3 instead of 2, the tests pass. So the shield didn't protect us for that change. And if you think about it, if you look at it, it's about the number of attendees. So let's add another attendee. So we got 2 attendees on this course. Let's take from this Dutch much limited company, like we do. The first attendee. So we got a change, of course. Let's see the coverage now. Okay, so we have destroyed some coverage here because of this added change, and that's because we actually only have we have 2 attendees and we have 0 attendees with a company. So we don't have the case where we have 1 attendee anymore. So we'll add another attendee, adding another input. And this time we need a new company. So this Sophie person will be from Sophie AB. Let's approve the changed input for both tests. Green, and let's see. If we're back at 100%. So we spotted a weakness in the shield, and we hopefully fixed it. When I change to 3 now, we hopefully get a flag from the tests. Yes, we got an alarm. So now we'll just say that we are confident enough with our approval test with our shield. So this means that we can start refactoring, and this part I really like. So we have a shield for our code now. We can be quite merciless, or we don't have to hesitate so much. So let's start just looking at something to fix. Let's start by removing some clutter. Just remove a bit commented out code. Let's see something like that. Let's see if we broke something. No. Okay. Let's look at these horribly named variables then. So non-Pythonic. So here, for example, number signed up. Why don't we call it something else? Attendee count, or the start guarantee threshold, which is directly from the attribute in the JSON file. Let's call it wanted attendees instead. So we got a little bit less hurt in our eyes. Let's see if we broke something. No, we didn't. Courses to print, another horrible variable name. Courses to print. Course to print. That's a mistake. Let's rename it again. Courses to print. Okay, run the tests. the approval test, and we are protected. And now we'll let's see. Yeah, we can. So this is quite a lot of duplication, right? It's just doing the same calculation over and over. So let's try to extract this computation, which is done in all 3 cases. Let's call it stat. We'll put it maybe above all the one, like here, somewhere. It have to be an F string. Let's run it again. Boom. We got an alarm. So look, this doesn't look right. We have just says stat. So, and the other test too. So why? Yeah, well, it's quite obvious when you look at it. It's got no curly braces, right? But our shield protected us from this mistake. Cool, we're green again. So when you do the refactorings, of course, it's better if you can use automatic refactorings instead of these manual things, because it's faster and more safe. So I'll just do this one with a built-in refactoring instead. Course description, something like that in the end. Let's see if we broke something. Probably not. Yep, great. Let's see some more things to do. Oh, this one. This is really annoying to do. Need to clean this up. It's just printed all over the place. So if you look at the report, it's just to do, need to clean this up, need to clean this up. It's just printed. What is this? Let's just remove it. And we have made a change to the production code, which we are fine with, so we'll approve it. And the same for the other. Let's go green. Great. So this looks horribly complicated. And if you look at what it's doing, it's classifying and it's checking the color, and then it's adding it to a list. And it's doing basically the same thing, but with different ways of adding. I don't know what's going on. So let's just take one of the sections and then comment out the whole thing. I'll do a little bit more brutal refactoring now. So like this we can do, and we'll have another section and a third section. It's just 3 different colors, right? Green, yellow, red. Let's see if we broke something. No, we didn't. Okay, so this is kind of the flow of approval testing. You build a shield which covers your code, and you increase the confidence by doing this mutation testing, and then you can refactor as you see, like when you have enough confidence. So let me get back to the talk, the presentation. So that was the end of the demo part. And if you want to learn more about approval testing, just contact me on LinkedIn or send a mail. So I think we have some time for QA now.
So, but as I can see, we have no any questions yet. So
okay.
Maybe we can finish with it. Yes.
Yeah.
Or you want to add something?
Or let's see if people say something.
We can wait a bit.
So I finished on time.
Yep. So I guess that's it.
Yeah.
And thank you, Olof, and thank you everyone for watching.
Thank you, Dennis.
Have a nice day.
You too, and all the viewers.